Okay, geology class. Today we're going to try something that I've never done before, and we're going to try to do a lab online. Not online, but the instructions for it online. This is the Streams lab. Since I promised you that you would have 10 extra credit points or opportunity for that, I wanted to make sure that that I gave you that. So what I'm going to do is post a series of video explanations, hopefully short, on Moodle that explain different segments of this lab. There are 10 questions to it. I won't need to do 10 different videos, but there will be a few. This is the first one. And they're meant so that you can stop, back up, relook at something, hopefully catch an explanation. I will try to give you a few more obvious hints for how to do some of these, or shortcuts in doing some of these questions, than I would if we were in lab. So here we go. So when we think about streams, I wanted to just open with this image right here. Thinking about streams, they're born, they live their lives, and they die. That's not a bad way to think of streams. Some of them are very old on Earth's surface, but here we have a youthful stream, because in this part of the country, given recent glaciation, most of our streams are very youthful, very young. And so in a young stream, it's a fairly straight course, fairly steep sides to it, probably a fairly fast current, which means downcutting is going to be really active there. And then through time, it'll begin to meander back and forth as slope retreat widens the valley through which the stream flows. Its gradient will decrease, and you'll see more of these. We call them meanders. Okay, and then later, as the stream reaches old age, those bluffs on the side of the river of the floodplain are a long ways away. They've been worn down by eons of erosion. The stream meanders all around, back and forth in the floodplain. So the floodplain is anywhere that that stream can exist. So through time, this stream will probably cut across this short spot right here, and it'll create what's called a cutoff. It will leave this stream, this portion of the former current channel, high and dry, and create what's called an oxbow lake. And then, through time, it may meander over here a little more. And so this stream will constantly be changing its course through this floodplain because it has a low gradient. It's depositing sediment. It'll erode sediment here on what we call a cut bank, because that's where the current is fastest. And then right here, it'll deposit it on a point bar, because that's where the current would be slowest. And so all these features would develop, as your lab manual talks about, as the stream ages. And so for question number 1, you are going to be filling out parts of this particular, of this particular chart. Okay, and you can turn any of this in, give me a screenshot, photocopy it off, tear out the page in your lab manual, whatever you want to do. Probably electronic submission might be better, but to give me your answers, any of those are fine to do. So here, the parts of this chart that I want you to fill out, and there will be a question set that I will post on Moodle, and we've already figured this out if you've watched this video likely, I will post it not on the lab page, but on the regular page, and I will send an email out to that effect. So I want you to identify whether or not there are meanders, whether or not there are back swamps. If we go back to this image here, in this case, this portion of the floodplain that is isolated from the main channel can actually be lower, because the main channel may deposit sediment here. In a flood, the main channel will have the fastest current, but if that floodwater jumps out of the banks, it will be shallower there, and the current then slower, and so it may deposit sediment along the edges of the river, creating what's called a natural levee. And behind that, you can actually get a back swamp developing. And so there is an explanation of those in your lab manual. So identify those. Oxbow lakes, are they there or are they not? Just a check mark is all I'm looking for. Yes, it's there. No check. No, it's not there. Cutoffs, I've talked about both of those. And then probably the most difficult thing will be the river gradient right here. This will be the biggest challenge for you. And so I'll go into a little more explanation there. And then you're going to want to do the approximate width of the floodplain and importance of downcutting and lateral erosion. Those are the elements that I want you to do. So if I go back to gradient, there are three maps that you're going to evaluate. The first one is the Missouri River near Leavenworth, Kansas. And if we zoom in on that area, oh, if I can, I got to move my face. It's usually a good thing. Get it out of the way. We're going to this part of Kansas. It is the one of the ominous federal penitentiaries there, Leavenworth, if you've ever heard it referenced. Okay, and this is the Missouri River right here. And so this is the portion of our country that we're going to be analyzing first. And so if you look at that Missouri River map, here is basically what we were just looking at. Now, what you're going to do to calculate the gradient is you're going to look for wherever a contour line crosses the river. Now, I just happen to know where a contour line crosses this river, so I'm going to zoom in on it a bit. Okay, right here is where a contour line crosses this particular river. And so you got to figure out what elevation that contour line is at. Well, you can go back and figure out the contour interval right here. It's 20 feet, okay? So that's the distance between any two contour lines. Remember what an index contour was. If you look out here, there's these darker contour lines. Some of them have elevation, they should have an elevation number on them. And since there's 20 feet between any two contour lines, that means there's 100 feet between any two index contour lines. So all that to say, well, I want you to look at this map and figure out its gradient. So there you got to figure out that contour line. Here's subtle hint number one. Right down here in the lower portion is a labeled contour line right along the edge of the river. You can assume that that contour is the same line as this one number down here. That's a big time savings for you. Okay, so then the elevation of the river here at this point where the contour line crosses it. You will then have to take a string and you want to lay it out on the bed of the river, on the course of the river, all the way to the bottom of the map. And you're going to kind of keep your finger on that string, because if we go back to this chart here down at the bottom, there's a footnote that you want to pay attention to. It says a supplementary contour with an elevation of 750 feet crosses the river 1.5 miles below the bottom edge of the map. Okay, using that information and the length of the channel that you have measured to here, this says 760. So the river is 760 feet high right there where it crosses, that contour line crosses. You'll know it's 750 feet high, 1.5 miles below the bottom edge of the map. So you take your string, measure to there, take that string up to here, top of the map, find out how many miles that represents, add 1.5 miles to it. You now have the length of the course of the river, and its drop. It will drop from 760 feet down to 750 feet. I want you to tell me its gradient in feet per mile. I believe that's what it asks for. Yes, feet per mile. Okay, you'll do the same thing for the Mississippi River, actually the Arkansas River. If we go back here to the Royal Gorge, actually I want the Royal Gorge Bridge. Okay, we're going just west of Cannon City, Colorado, west of Pueblo, south of Colorado Springs. Okay, maybe you've been to this spot. This is the Arkansas River, or if I've been corrected, somebody told me it's the Arkansas River, so a local did. So just to give you an idea, if you put the cursor down here, down at the bottom, it's somewhere around 1,540 feet. Up at the top, it's 6,500. This is basically a 1,200 foot drop, and it's fairly vertical. They have a spot right here where you can pay to be bungee shot out over that Royal Gorge. I can't imagine paying money to do that. If you look in this area, this is obviously very steep walled. You can get an idea for that as I move the cursor around. And if I zoom in on the Royal Gorge, and I think I can, yeah, right here, we can go stand there, and if you haven't seen it, put it on a list of places that you want to see at some point in your life. Oops, where did I go? Oh well. That's what the Royal Gorge looks like, and the bridge going across it. Okay. All right. So you'll use this map. Okay. And a subtle hint. Right above the A in Royal, there's a contour line that crosses. And down here, there's another contour line that crosses right there. And so you can determine your stream course length with a string again, and that legend at the top. And you can use those two contour lines to figure out the drop and give me a gradient in feet per mile. And then lastly, we have the Mississippi River at Vicksburg. So if we go to Vicksburg, Mississippi, I had a great-grandfather got wounded there in the Civil War. Kind of interesting place. Actually, if you're from White Bear, Highway 61 goes right through Vicksburg, I think, if I remember right. Just hop on that and away you go. So we're looking at the Mississippi River here, and if I put the cursor here on the edge, you can see it's 135, 200 feet here. Then we go down on the river plain, it's 70, 80 feet. You go all the way across to Monroe, Louisiana. That's where the Duck Dynasty boys are from. And it comes back up to 100 feet. So this has got a tremendous floodplain. And this is obviously got a lot of meanders to it. Old oxbow lakes, former cutoffs, all kinds of stream features in the Mississippi here. Okay, if we go to the map then, Mississippi River, there is a contour line right here that crosses the Mississippi. And to give you a subtle hint, if we follow that down, let's see, I guess I got to zoom in just a little bit here, folks. If we zoom in right here, these are dashed, so they're called supplemental contours. They're halfway between two regular contours, and the contour interval on this map is 50 feet. So the one closer to the river we're going to assume is a little bit lower. The one farther away from the river is a little bit higher. So 75 feet, we'll assume that this one right here, this is a fair assumption to make, that right here, that is at 50 feet elevation. Okay, now we go back to our chart right here, and we notice another footnote to pay attention to. It says there's a 100-foot contour, so that was 50. This is 100-foot contour that crosses the river 74 miles above the top edge of the map. Okay, so we go back to here. You take your string from this point right here, your best estimate of the main channel, okay, kind of middle of this main channel up to the top of the map. You get your distance. You calculate what that string distance represents here. You add 74 miles to it. You know the river has dropped 50 feet from up here, 74 miles, to this spot by Vicksburg, and you can calculate your gradient. All right, so hopefully that makes some sense, and you'll be able to do it. I'll put some others on that will not be nearly this long. Thank you, and that's it.